Well, hello. I'm just a little worried that we're not going to get through everything I want to get through in 2.7, so I thought I'd record a video and make sure you have it. So section 2.7 is about finding square roots and about comparing real numbers. And we've done some of this already this year, but I want to make sure we do the formal notes piece of it in case that's what you're looking for. So first of all, a square root. When you're asked to find the square root of a number, remember we're trying to find what number times itself gives us the number that's under the radical symbol. So they give you this very mathematical definition. If b squared is equal to a, then b is the square root of a. Square roots are written with the radical symbol. That's what that little square root looks kind of like a division with an extra little hook. The number that's under that radical symbol, that's called the radicand. Perfect squares are the ones that we are pretty familiar with. They're the ones that are made up of 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. And I hope you're getting the picture here. And really, all the way out to this last one here, 14 squared, you should really have those memorized. Again, another flashcardable thing, but you're going to see these so often over the next 4 years that if you might as well memorize them now. So really, everything from 0 all the way up to 400, that's 20 squared. Those would be the ones I would suggest memorizing. But I'm not going to test you on that yet. The next word there is an irrational number. Remember, we've already talked about those. Those are numbers whose square root is not an integer, or a number that cannot be written as a fraction, right? By definition, irrational means we can't write it as a fraction. And then that last vocabulary word there is the real number system. Remember, we actually talked about that in section 2.1. That's that symbol that looks like a paragraph sign, but it's actually an R. And it's all the numbers that we've ever been familiar with. There are also imaginary numbers, and they're what happen when there's a negative under the square root. But we're not going to have those. Under. Maybe on the outside, but not under. So now let's keep in mind here these examples. Example 1 says, a square root of a number. Find all the possible answers to the square root of 25. Since 5 times 5 is equal to 25, and negative 5 times negative 5 is equal to 25, there are two possible answers. You could have 5 and negative 5. So, when we look at these problems, just remember that if it's a number that we're pretty comfortable with, right, a perfect square, then we can just go ahead and simplify. So this problem is asking me, what's the negative number that has a square root of 36? So the negative number that has a square root of 36 is negative 6. Or another way to ask that same question, what negative number times itself is equal to positive 36? And we already wrote our answer down. The negative square root of 36 is negative 6. So let's look at the next couple. So 19, it's asking me for the square root. Oh, well, my number didn't. Wow, this whole thing going all the way across here. This question is a really bad question, so let's clean it up. Let's go ahead and change it into not a 19, but instead a 16. So this really should say the square root of 16, or it could even say 196, but let's go with 16. So this one's asking us what's the positive number that has a square root of 16. So what positive number times itself is 16? Well, the positive square root of 16 is, you're right, it's 4. And then the last thing we need to talk about is this symbol here, this plus or minus, or plus and minus. So we need to consider both answers. So what is the positive and the negative square root of 64? Well, positive and negative number times itself is equal to 64. And hopefully, negative 8 and positive 8 stand up to you. I'm pretty sure that those are familiar. But I'm not so sure that this symbol is one you've seen before. So again, it just means that we need to consider both the positive and the negative answers. Let's go to the next page. Now, what about the square root of 8? 8's not on that list of perfect squares. So what are our options? Our options are that we should use our calculator, or we can think about perfect squares that are around 8 and approximate. So if we think about this number 8, the very next number that would be a perfect square is 9. And the smaller number that's a perfect square is a 4, right? 8 is in between 4 and 9, because that's a true fact. We know, right, square root of 8 is in between the square root of 4 and the square root of 9. Let me rephrase it. Because we know that 8, the number 8, is in between the perfect squares 4 and 9, we know that the square root of 8 has to be in between the square root of 4 and the square root of 9. The square root of 4 is hopefully one that's familiar, that's 2. And the square root of 9 is a 3. So the square root of 8 is somewhere in between 2 and 3. Somewhere in between. It's a decimal value, and I would guess, because I don't have my calculator right here, that it's about 2.8 would be my guess. I'm going to go ahead and pause, pull up my calculator, and then double check it. So you can see right here that I've got my calculator up, and the square root of 8 is in fact about 2.8. Switch back over here to our notes. So then how about the negative square root of 45? Let's do that whole process again. So 45, what would be a perfect square that's bigger? The next perfect square, 49. 7 times 7, which means that the one that's smaller is going to be 36, or 6 times 6. So the square root of 45 has to be somewhere in between the square root of 36 and the square root of 49. So that's in between 6 and 7. And since they asked us for the negative, so we'll have a negative 6 point, again, I'm guessing, I'll grab my calculator here in just a moment. I would guess, what, 6.7? See what happens. I'm going to use my calculator and check it out. There we go. So I want to take the square root of 45, and it's equal to, oops, yep, 6.7. Which is exactly what I said. Notice that because the negative is out in front, and then I put a negative into my answer. So once we got that part down, then the next piece is nice and easy. Everything else from here out is easy. Tell whether each of the following numbers is a real number, a rational number, an irrational number, an integer, or a whole number. We're pretty good at these. Remember that everything that I'm going to give you is going to be a real number. I'm not going to play any imaginaries. Just want you to know that they exist. The square root of 144. Well, that's really a 12. So 12 I can write as a fraction. 12. Is it something I'd be comfortable with if I got an answer? Yes. How about a whole number? Is it a whole number? Yes. As a matter of fact, it goes all the way down to the natural numbers. Good. Let's finish these guys up. Negative the square root of 49. So we're really evaluating or identifying families for negative 7. Yes, it's real. Can I write negative 7 as a fraction? Yes. So I don't even have to worry about irrational. Is it an integer? Is one of my comfortable answers? Yes, it is, right? It's a whole number and it's negative. It's comfortable. How about that whole number? In this case, no. Because in order to be whole, you have to be 0 or positive. Now the square root of 32. Is it on our list? Nope. Somewhere in between 5 and 6. So it's a decimal value. So could I write it as a fraction? No, because it's a radical that doesn't simplify. So it is not rational. It is in fact irrational, which means it can't be any of the others. All right, so we just have 2 more things to talk about. First, graph, then order the numbers from least to greatest. So go ahead and use your numbers here very carefully. So the square root of 16, well, that's really a 4, so we put our point on there. And we'll label it with what they gave us, the square root of 16. 5 halves. So from 0, 1 half, 2 halves, 3 halves, 4 halves, there's 5 halves. Or make it a mixed number, it's 2.5. Make it a decimal, it's 2.5, whichever way you need to do that. Again, we'll label it with what they gave us. The square root of 4 is here, right? Square root of 4 is 2. A negative 3 is down here. And the negative of a square root of 6. So the square root of 6. 6 is in between 9 and 4. So in between the square root of 4, and the square root of 9. So in between negative 2 and negative 3 is where that value will fall. Negative the square root of 6. And once we have all of those on the number line, then being able to list them from least to greatest is pretty easy to do. Negative 3, negative square root of 6, square root of 4, 5 halves, square root of 16. So be prepared for that. And then last but not least are the evaluate problems. So this one says, if do 12 times the square root of y, if y is equal to 25. So 12 times the square root of 25, that's just to do 12 times 5, which hopefully you have memorized, is 60. Just be cautious, make sure you follow the rules as you see them. So this we need to do negative 9 times the square root of 100. Notice that this minus 5 is not underneath the radical. So then subtract 5. So negative 9 times 10, then subtract 5. So it's really negative 90 minus 5. So we end up with a negative 95. So don't panic about these problems. Why don't you go ahead and give problems C and D a try, pause the video, give them a try, and then come back and check your work. So our last bit is checking your work here with C and D. And hopefully you didn't find yourself having too many troubles with this. Just be cautious with that positive 2 plus negative 23. I have $2 and I owe somebody 23, so I'm really only in the hole or owe negative $21. I only owe $21. Square root of 1 is a 1, so be cautious with it. So we end up with a 1/2. Hope you enjoyed 2.7, and I'm going to try to record a review video for you as well.